Alright, we left off with the cloud mask construction. As I said, the rotator actually controls the UVs for all the textures. Well, all the channels of the textures. We've brought in separate UVs and panners for 4 instances of the texture simply so we could have variation. If you were so inclined to make this as optimized as possible, all of this could be through one UV sets, one rotator, one panner, and then all these could break off of their own, but I like the modulation that giving these different speeds actually ends up giving it. I also put in a controlling parameter for how much of each of the channels is added in. Again, not something that's necessary, just extra controls that I ended up using. Once I got all the channels in, I send them through a lerp. First the red and the green channel, alpha being the green. The alpha I found doesn't actually matter that much as long as it's a mid-tone gray and adds in both. Then the blue and the alpha, and then through another lerp I send those two, and I end up with this modulated texture. That then goes back, actually it's the red and green channel that then go back into the cloud wipe to add the modulation that you see in here. Before I add that in, you end up with just this straight gradient. So that kind of adds that cloudy build-up. The next little bit is the color gradient. You can find this in the UDK default skies as well. They do it pretty much the same way. It's just a simple lerp based on a texture coordinate mask, and then that gets added in with the clouds later. The UV modulation I added just for that extra little bit. It really is entirely unnecessary. It's just extra fluff, as it were. This takes the UVs and adds in a animated and very non-tightly tiled red and green channel. It just adds those into the UVs, and it creates this kind of cool wispy modulation. The lighting got a little complicated, but I was able to pare down most of the unnecessary work. I originally had normal maps for each of the channels, but I found that was pretty much unnecessary as the red and green channel were the most important. So I just add those together, normalize them, and then bring them in through a Fresnel effect, multiply it a bit, and bring that in as rim lighting. I found that bringing in the same mask that actually masks out the clouds, but then actually reversing them with constant clamp and absolute, multiplying that in actually gave me a much better edge. I originally tried copying the defaults, but it just didn't look quite good enough to me. So the sun setup, pretty similar again to the defaults that you can find in UDK. It's using a camera and light vector and a sphere mask to give us our sun, which you can see up there. I kept a parameter so that I could change the sun color as I wanted to. The cloud shading is actually controlled by this lerp that's brought down into a constant bias, sent through a power to give it some more contrast, and then that just lerps between a high and a low for the cloud colors. There's very little white in this, so you'll almost never see this pure white color. And you can add more contrast as you need to, but I found actually keeping it moderate contrast really gives it a better look. The cloud shading and the rim lighting and the sun are all then added together, or multiplied and added together, and brought in to the custom lighting. Oh, I guess I should go over the fact that this is set up with a custom lighting model. Blend is opaque. Other than that, this is pretty much a standard material. I did put two-sided on, although it's not really necessary. That was for a experiment. And that's pretty much it. Then the clouds are then brought in through and put through the same mask that masks out the lighting, and put through a lerp, and that adds in the sky color, and then that's put into the emissive. Again, I just wanted to do a quick overview, not a full tutorial. I am going to include a full-size map so that you can really take a look at how it's constructed. Most of the important bits I've already gone over. So yeah, have fun with it.